We talked about domain restricted functions so that we could look at graphing piecewise defined functions. If you look at this example of a piecewise defined function here, you can see that each piece of the graph has a different domain restriction. Before we look at graphing, though, we want to talk about evaluating functions. So a piecewise defined function is a function defined by different equations. If you look at that example, you can see that each piece is a different equation. And the different equation belongs to different parts of its domain. Remember, the domain is the x values, and we're changing the domain restriction for each piece of this function. This function here has 3 pieces. We're asking you to evaluate the function for different values of x. We're asking you to find the g of -1. If I look at my domain restrictions, I see that -1 is less than 0. That means I substitute -1 into this equation. The g of -1 equals 1. When we're asked to find the g of 0, we see that x equals 0 for the second piece. That means we use this equation. There's no x value here. The g of 0 simply equals 2. In the last question, the g of 2, we see that 2 is greater than 0. So we use this equation and we substitute 2 into that value of x. The g of 2 equals 5. Let's look at another example. The f of x also has 3 pieces. Why don't you try evaluating the f of -2? I see that -2 is between -3 and 1. I'm going to use this equation. We're going to substitute -2 into the x. So we have 4 plus 1, this equals 5. Evaluate the f of 1. The f of 1 is here, where x equals 1. Again, there's no equation. It's simply -3. What about the f of 3 and the f of -4? I see that 3 is greater than 1, so we're going to use this equation. The f of 3 equals 9. Doesn't like my 9. There we go. What did you do about the f of -4? This is only from -3 to 1. -4 is less than -3. X has to be greater than or equal to -3. I can't evaluate the f of -4 on this graph. There is no solution because this value of x does not appear in the restrictions for this function.